Welcome to the Universe CyberRes closing keynote. My name is Tony de la Lama and I head up products for CyberRes. Hopefully most of you saw the CyberRes opening keynote and our focus on securing the software supply chain, including a discussion of the many threats faced by companies of all sizes. For today's closing keynote, we decided to take a deeper dive on the issues and supply chain threats we face and how CyberRes can help improve your security posture and cyber resilience. We decided to take a different approach this year. Hope it's okay. More informal, no slides, just our team of product leaders who are experts in their field, sharing their experiences, knowledge, and insight into better securing the software supply chain. First, let me introduce our panel. Nikols is the product leader for our NetIQ identity and access management portfolio, and also CyberRes's VP of strategy. Dinah Thomas, who you also heard in the opening keynote, is our product leader for our Fortify application security portfolio. Greg Clark heads up our data discovery and privacy products in the Voltage portfolio. Mychalczuk is the product leader for our ArcSight security operations portfolio. And finally, Stephan is the CyberRes CTO for security analytics and an AI ML expert. Well, let's get started. Nick, securing the software supply chain is a big problem to get your arms around. How should we think about this problem from your perspective?
Well, actually, it's interesting that this isn't really anything new. I mean, we've been doing a lot of different things and different aspects of securing the software supply chain for quite some time. This ends up becoming part of good practice around secure DevOps, for example. But what's really garnered a lot of attention around this is the more recent executive order 14028 that came out back in May of 2021 that really brought a lot of attention to the whole notion of securing the software supply chain. And as part of that, it was really a call to action around bringing these different best practices to bear. And so in particular, there was this view of, how can we use some of these other approaches that have already been, in the works and developed and flesh them out further. In particular, one that really got revamped somewhat is the NIST Secure Software Development Framework, which is NIST 800-218. And in that, it really calls out some really, I would almost say common sense, sort of best practices that can be employed around this. This comes to things like, what can you do to prepare your organization to better secure the environment? So making sure that not only you're looking at this from a technology standpoint, but also from a people and process standpoint, and bringing the right people together with the right roles and responsibilities to guarantee a smooth process. Also, the other best practice that they call out in NIST 800-218 is the steps that you take to actually protect the software. What do you do to make sure that the software is not susceptible to unauthorized access? What do you do to ensure that nobody can tamper with it? Okay. And then, how do you go about producing the fourth item is producing well-secured software. So this is employing all the techniques around, securing the software itself, ensuring that all of the right engagements are in place, for ensuring that you're not introducing vulnerabilities into the software, but also ensuring that the software is operating in a secure fashion and isn't susceptible to abuse. And then finally, the last step of this process is really around responding to vulnerabilities. And so once you find a vulnerability, what do you do to mitigate that effectively? So these are, really, I think, like I said, common sense guidelines to really follow. But this also, I think, summarizes a lot of what we do within CyberRes, because we provide capabilities across our entire portfolio at each of these levels. And so for an example, with what we do specifically from an identity and access management perspective, which is part of the portfolio that I'm responsible for, is really, we can help organizations from a prepare the organization standpoint by helping define the appropriate roles and putting in the right controls around enforcement around what those roles and responsibilities should be, and making it easier for the organization to really ensure that the right people are involved at the right levels in the process. And then from a protect the software standpoint, we're also able to protect that access, make sure that we can guarantee appropriate access and prevent unauthorized access, and ensure that nobody has the opportunity to tamper with this. And this comes through our approach with doing things like supporting zero trust architectures, which is also another thing that was called out in the executive order, and also facilitating least privilege access. So from this perspective, I mean, this kind of gives you an idea of how identity really plays a key role in this kind of security. But there's also many other aspects of our portfolio that play well, and as some of our other panelists will cover in more detail, can illustrate.
Nick, you brought up something here, and I just want to bring it up here because we talked about it in our meeting ahead of time. Was you mentioned explicitly the executive order and NIST, and there could be some on the call who would sit there and go, well, you're talking to Americans. But let's be clear, that's not what he's doing. He's using, I would say you're using the executive order as a catalyst. It was just something for us to catalyst the conversation around. It just happened to be a U.S. executive order. And NIST it tends to be one of those favorite areas because it tends to be more prescriptive in some ways than ISO itself. But we're not just trying to move this conversation to one geography. We still believe it's universally acceptable.
Absolutely, couldn't agree more. And again, this was it really spurred a whole bunch of conversation, because of the emphasis that was placed. And in general, I mean, even in other NIST initiatives, like the NIST Cybersecurity Framework, for example, these are broadly adopted internationally. It's just, again, these are just frameworks, guidelines for best practices. And so, from this, I mean, it's one of those things is that we can all improve our practices. And by looking at these different, categories and sort of taking, learnings away from, or from that and internalizing that helps us all improve our overall security posture.
Yeah. One thing that stood out to me too, Nick, with the focus on frameworks is that, whenever we have these, big events like Log4j most recently, right, or SolarWinds last year, there tends to be this, kind of very violent reaction. And in some ways, not necessarily an overreaction, but we tend to lose sight of the bigger picture. So there's a focus on how can we go retroactively respond to what just happened. But these frameworks allow us to step back and say, how do we get a little bit more proactive in what we're doing, and then drive the systematic, processes that you alluded to help position us to better respond in the future events that will happen that will have a different impact on the supply chain.
Yeah, absolutely. I mean, that's a perfect example, I think, of responding to a vulnerability that was called out, in this particular framework. That I think that's been the hell that we've all lived through over the holidays, and so being prepared and having the right path, in place, goes a long way to dealing with this quickly and effectively.
Well, Dylan, you spoke about the role of AppSec in the software development lifecycle at the keynote. What specific thoughts do you have in this area from your perspective?
Sure, Tony. So, in the keynote, I broke out and focused particularly on dependencies. And so, but one of the areas I didn't spend quite as much talking about was around software bill of materials, or SBOMs. It's a term that's been probably ramping in usage over the past years. It's called out in the NIST software development framework, and and for good reason. So again, but admittedly, I just said let's not overreact. But let's also look back at Log4j as an example, right? It's imperative that when a new vulnerability becomes present, that we need to quickly, as an organization, respond. And to do that effectively, we need to know what our exposure is. That's something that fortunately we were proactive in Micro Focus about in terms of having good practices in place to know across the entire enterprise where components like Log4j exist in our database of open source. So that then drives our ability to quickly act and respond, and then furthermore, drive communication internally and externally. I think looking back on this a little retroactively, what are some things we would do differently? I think everybody learned a little bit in this situation. For us, it was evolving our communication processes. I think we had we internally responded well, but we have an opportunity as an organization, and we've implemented practices to do a better job communicating externally how we respond and how we're helping secure our customers. That was one thing that stood out from the Fortify perspective. So, with this group of other product leaders, I'd just be curious if anyone has any insights from their experience just responding, just like many of our customers would to a supply chain threat like Log4j.
Well, I would have completely agreed with you, is that we knew within just a few hours in the ArcSight world and in SecOps, we knew very quickly where Log4j was and all the places it was permeated. For us, it was improving our communication processes. The other thing that we learned in ours is that because of our history and heritage, we didn't just have one implementation of Log4j within ArcSight. We had multiples, and in some product areas, we had as many as 4 and 5 instances of Log4j. So for us, it was not only did it, and these were areas that would have otherwise gone, I won't say undetected. That's not the right word. We knew where they were, but they were kind of out of sight, out of mind. And so then it became okay, now we need to go back and not only fix this, but then look at, why do we have it the way that we do now? And so it's also causing us to mature in an area where we might not necessarily would have in the past, left to our own devices.
You made a really good point, Mike Hendilen, in that one thing that we have here at Micro Focus and CyberRes is a very robust governance program around open source when we use it. And that was really important in this particular situation. And that you're right, within hours, we knew exactly where Log4j existed in all our products. And we were able to start taking immediate steps to try and fix it. Now, that's the first step, no question. Remediating, pulling it out, or making changes. That's really the hard part. But there's a lot of organizations that may or may not even know where open source is deployed in their applications, and so very, very important aspect of protecting yourself.
Yeah. And Tony, I think, and that just to kind of bring that back, that just highlights the importance of software bill of materials. And I think the expansion of that they'll take across the industry, because they'll help us protect from that. One of the things I would also mention, though, is, again, I talked a lot about dependencies yesterday. I'd love to take this as a chance just to highlight some of the other interesting considerations from an AppSec perspective when we think about software supply chain. So one of the trends that we're seeing as we talk to customers and partners across the industry is a better recognition of those attack vectors I talked about yesterday, and particularly the ones around insider threat. Fortify is actually a leader when it comes to deploying automated static analysis technology to detect insider threat patterns in committed code. But historically, those are very noisy, and the trade-off of all the noise that gets generated wasn't worth the attention that it took to go execute those tests. We've seen, because of the emphasis on supply chain, we've seen a renewed interest over the past year in particular in leveraging those type of capabilities to mature processes beyond just looking for known vulnerabilities and dependencies. Looking inside your custom code, what if a user is compromised, credentials are compromised, because of insecure access control, like Nick alluded to, and they're able to commit malicious code. Having automated detection capability in your DevSecOps process would be very powerful in those circumstances as another layer or defense in depth. One of the other things I'll just mention as well is just we're seeing increased interest in attacks against the CI system itself. Well, we all know about infrastructure as code and everything is code. Well, CICD is also now code. One of the very interesting areas of research that's come out over the past year or so is around how we understand attack vectors against that CI system, as folks write code to define it. This is potentially powerful because it allows us to systematically monitor and have version control of how systems are configured, but it introduces new attack vectors. If we take GitHub Actions, a very popular and ramping CI/CD system, there are multiple ways of introducing arbitrary code injection attacks if you're not careful with how you define your GitHub workflows. Fortify's seen this. We've worked with other researchers, and we're also emphasizing how we can help users proactively scan their CI/CD as code, just like they'd scan areas like infrastructure as code, to help prevent these style CI/CD attacks.
Mm-hmm. And another thing too, just to add to that, is as you're dealing with the CI/CD process, we have to also keep in mind that this is another layer of areas where we have to put in the right access controls. So you don't want to have this to be too open. I mean, the whole point of these elements, the software itself, the repository, the infrastructure as code itself. These are resources that need to be protected, and we need to make sure that we're providing appropriate access. So giving the right roles and responsibilities throughout that process, making sure that only the right developers get access to things like the production-like environment that they're supposed to be developing towards, making sure that as they look at the different repositories that they're engaging with, that they're have the right access there, and ensuring that they're maintaining their right position in the process. So, for another example, is not to have developers have administrative equivalency in production, because that's if you open things up too much to try to speed the process along, you can actually open yourself up to these kinds of attacks. And so having all of these different layers in play, and the right controls across the different dimensions, I think, is a very important thing to be considering.
I'll add one quick thing with respect to access control and insider threat. So it's important to understand that when you have insider threat, standard access control is not sufficient. What we need is sort of AI augmented access control, because with insider threat, what you really have is an authorized user who's performing authorized actions, running authorized applications, accessing authorized data, but they're still behaving maliciously, right? That's the nature of insider threat. So in other words, this is where AI becomes incredibly useful, because what you're doing is you're using techniques like anomaly detection to learn what is normal behavior for a specific user, but that user is not behaving normally. They've been compromised, they've gone rogue, they're behaving maliciously, and that's where AI, and in particular anomaly detection, which has been Intercept's bread and butter for 7 years, is really, really important. In fact, we found some of the most sneakiest of adversaries that have attacked source code systems in the past. It's been quite remarkable. My favorite story from last year was a developer who maliciously tried to steal source code, but he did it in a very sneaky way. This developer was brilliant in an evil way.
An evil way.
Instead of taking the source code and just mailing it to himself or copying it to a USB key, what he did was he opened up the source code files, paged through them screen by screen, took screenshots, took all those screenshots, and then sort of sprayed them across multiple Gmail accounts to try and basically bypass any sort of threshold-based system. We still found it, because obviously all the behaviors, again, he was authorized to access the source code. He was certainly authorized to run screen recording software, but we still saw it because the behavior was just so anomalous. So I just wanted to sort of add that point.
That's a great example.
Well, Stephan, since you kind of took us there with the insider threat, maybe you could take us further. What else have you seen in how AI can really be brought to bear to help solve some of the issues and problems we're facing here?
Well, absolutely. This is a great time for AI. I know it's a bad situation for the industry, but I'm kind of really excited about the opportunity. Dylan, you talked about the Backstabber's knife collection and the analysis that was done by Ohm last year, just analyzing all these malicious software packages and looking at real-world attacks and looking at a consistent pattern of behaviors attacked by a consistent pattern of behaviors described by attack trees. Everything from how malicious code is injected into the dependency tree to how that code is then executed in the victim environment. Well, if you think about it, all these attack trees, these collections of repeatable behaviors, that's essentially doing for the software supply chain what the MITRE attack matrix did for sort of standard advanced attacks against the enterprise. So this catalog of behaviors is honestly perfect for AI, right? It means that just like how we have models today for all the behaviors across the vast majority of the MITRE attack matrix for advanced attacks, we can build those same models on behaviors using anomaly detection for the entire sort of software secure chain. And that's a great opportunity for me. I do want to add one thing that I'm really excited about because I'm sort of known for looking ahead into the future. For the past 2 years, there's been an amazing renaissance in AI in an area called large language models. You've probably heard of deep learning. You might have also heard of GPT-3, which is an example of a large language model, which was released last year. This is a massive model. It's got over 170 billion parameters. So it's the biggest of all deep learning models. I think for a long while is the largest model in existence. And basically they took this language model and they trained it on text. So it read all of the internet, most of it at least. It read all of Wikipedia for sure, read hundreds of books, maybe thousands of books. And they eventually trained it to be able to have a human-like conversation, write poetry. And I had a lot of fun actually taking this large language model, and I trained it to write my stand-up emails for me. That was great. And I actually got it to write a poem about AI at Micro Focus. And it was pretty good. Maybe you can give that poem to Tony and he can sing a little song about it with his guitar. I do think, however, in all seriousness, I think the same type of approach can be used to train an AI to read source code. And the opportunity here is that we're moving beyond just behavioral analysis, which is the behavior around source code repositories. And we're now looking into the malicious code itself. And this is harder than standard software vulnerabilities. We're looking for things like buffer overruns. In this case, the main difference is the intent, right? When someone is intentionally adding malicious code to your source code, they are probably going to obfuscate it. They're going to hide that code. They're going to divide it up. They're going to sort of take strings and slam them together. They're not going to do things in an obvious manner. So that makes it harder than standard code analysis approaches. So I truly believe that taking a large language model approach, like what GPT-3 did to read poetry, can now be applied to actually read and truly understand coding in a way that is much more scalable than relying on a large team of human experts, which no one has enough of. So I'm pretty excited.
Fascinating. Well, thinking about, when we think about applications and we think about software development lifecycle, a very important component is data security right along with that. And Greg, I'm wondering what your thoughts and thinking are around data security as it relates to securing the software supply chain.
Yeah, thanks, Tony. Let me just tie a bit of what Dylan and Nick talked about into a real-world scenario. So we were dealing with a customer who had, and when you look at those platforms, whether it's Git or Artifactory or things like that, this particular customer had a bunch of Git pages that were overexposed, like Nick was describing, and inside of those pages were clear text passwords, a lot of intellectual property, there was APIs. A lot of that data was considerably valuable to the organization, and it was open, completely open to 130,000 employees for the first 6 months. So those kind of platforms are really overlooked in terms of how do we protect information that's in there. And again, what we're seeing on the data security side is, if we start with data at the center, organizations just like Micro Focus, we're addicted to data, right? The growth is unrelenting. The cloud repositories, cloud data warehouses, Hadoop data lakes. I mean, we are just pushing data out, duplicating data, and the attack plane is just so big when it comes to our structured and unstructured data. When you look at things like Nick was mentioning, the executive order, directives like that, internal mandates, whether it's we're shifting to cloud or we're making sure that we can comply with sustainability mandates that the board has brought forward, or global data privacy regs. Those are all adding complexity to our customers' environments, and it's a real and present danger both to the reputation of the firm or the organization, but also at the bottom line. So when we look at it through the lens of data security, we also want to be able to be proactive, like Dylan described. So understanding information, understanding where sensitive data resides, understanding the value of that data, and being able to take protective measures against outsiders, or ensuring, like Nick said, the right people accessing the right information at the right time, as it relates to NIST. Those are things that we do inside the data security and voltage portfolio that allow us to really be much more proactive in terms of helping organizations shore up the vulnerabilities around their sensitive data. So when you look at it through another lens, and you say, okay, data is growing at an unrelenting pace, but how does that really relate to the software supply chain? Well, application sprawl is becoming more prevalent as well. So more and more IT is becoming creators and consumers of software, just like us, right? They're rolling out more applications, more tools, they're developing more code. So looking at it through the data discovery, from a data discovery perspective, is being proactive and being able to identify as that data is checked in, being able to identify that there is sensitive information, maybe not through the data privacy lens, but looking at things like clear text and other vulnerabilities in terms of trade secrets and whatnot. That is really critical to securing the software supply chain as it relates to data discovery. So being able to be upfront and assisting as that data is checked into these repositories really starts to complement the things that Nick does over on the NetIQ side in terms of authentication, and augmenting things that Dylan is doing on Fortify, and help support from Mychalczuk's side over on ArcSight, as those areas and that data is being acted upon or is being accessed, and really trying to understand what's happening around the data is really where Mike comes in from the ArcSight side.
Hey, Dylan, I'm curious about something. I'm listening to Stephan and I'm listening to Nick and all in those areas. And one of the things I was curious about is you had some, I remember in a conversation somewhere you had started once to talk about there were some patterns or something around how developers choose software independencies. And there was an area where you had been looking around some of this area, but it seems like it ties in great to this conversation, especially with how Greg is talking about data as well. And I think that all fits together.
No, great seg, Mike. And it's interesting. So much of what we do is downstream from the original decision of what gets incorporated. So whenever we're bringing in, the decision of a new component, for example, and bringing in new open source, that's actually such a critical inflection point that is often overlooked, because everything else is responding and reacting to that decision. What's exciting these days, complement some of the areas that Stephan talked about in the AI/ML space, is how we leverage the massive amounts of data around the open source community, for example, or even other areas too, like containers and other pieces of third-party code you bring in to make smarter decisions up front. So if we look at pulling all that information together, whether it's how developers are, what does the community look like around a given piece of software? What are their practices of how they engage, how quickly they respond to security events? There's just so many data points that if we can leverage these advanced AI models to automatically recommend, hey, I see you're trying to solve this problem. maybe you should look at these 1 or 2 or 3 solutions that are well supported by the industry that would suit you moving forward, so you're not in in some of these dangerous situations that you can lead to from dependency confusion and typo squatting, or even just a project being abandoned.
Yeah,
Dylan, can I ask a question of you just quickly? So when we look at it through the data protection lens, we've seen organizations in terms of that clear text and password scenario that I was talking about, Git pages. We had a use case there where the organization just wanted to delete the information. I see other use cases where you would want to obfuscate sensitive information where it would have some utility to the organization. In terms of the software supply chain, do you look at it as the removal of that information, or do you see other use cases where we would want to anonymize or mask data in that context?
Yeah. I think the easy answer is it depends, right? If anyone remembers back to business school or their world, right, the answer is always it depends. And I think the breadth of what we see is that different applications and different businesses will see the need for different use cases. So having all those tools in your belt will help our eventual community of users more effectively choose the right hammer for the right nail, if you will.
Gotcha.
I'll add that the benefit of the software supply chain is its openness. So Dylan, you touched on this. The fact that everything is out there, all the PRs and GitHub are visible. You have access to see the community members. You have access to the behaviors. And so you're exactly right. There are ways in which you could apply analytics, AI, ML to all that data. In fact, there's a line of research going on across multiple universities right now that is actually looking at the code in open source repositories, because they're all quite accessible, right? So that's a huge corpus of data to analyze. So you can analyze that, look for patterns, look for recommendations. This package is more secure than others. And if you think about the other problem with the software supply chain are all these transitive dependencies, right? When we had to when we had to identify usage of Log4j, it wasn't just Log4j directly used by our products. And we need to find Log4j being used by package A, which is then consumed by package B, which is then used by our products. So it's fortunate that we had all those systems in place. But without some sort of automation to be able to do all that analysis across the entire supply chain, across all the transitive dependencies, you can't do that with humans alone. You really do need machinery and algorithms and mathematics to be able to pull off that trick.
Yeah, and having, I think, seeing the industry, starting to have tools publicly available, like like Open Source Select and these other places, are really a key enabler as we continue on that journey.
Sounds good, Dylan. Thank you so much. I'd like to see if maybe we can hear from Mychalczuk and the role of SecOps and SIM in ensuring that we keep our supply chain secure. Mike, what are you thinking?
Well, it's been great listening to this discussion, because I have a physical security background as well as a cybersecurity background. And there's a model of security that was put forward many years ago, and it's called a time-based security model. And it's basically the time you are exposed to a threat is equal to the time it takes for you to detect plus respond to the threat. And if you start looking at what we've been talking about today, we've talked about, just in a very short order, the sheer complexity of supply chain. And so most organizations tend to look at the supply chain from a logistics point of view. In terms of building the widget, they tend to look at it holistically, because they know that all the widgets must go together to result in the product that they ultimately produce. But one of the things I've observed in talking with customers and listening to Dylan and Stephan and Nick and others as they share their experiences, is that in the case of the supply chain's individual components, when you start getting down into software supply chain, when you start getting into some of those other areas, it's very siloed. And when I go and I talk to security operations teams, I find very few security operations teams that are really willing to take on the the CI environment or the actual operational monitoring and analysis of the security ramifications within that supply chain. And you start looking at the whys behind it, and you get to a couple of interesting parallels that I see is that one of them is, well, there is simply too much data. And I sit there and I go, really? You're already collecting mountains of data from all the other security devices. How does the application supply chain, if you're developing apps, really pile on that much more work? But then when we start getting further into it, we realize it's less about technology, at least in my observations, and more about the religious and the political dynamics of it. The idea that if we apply the security disciplines that we need to in the supply chain, that it will slow us down. It will inhibit our innovation. It inhibits our ability to act and react to the market needs. Why? Because the security people are only interested in basically keeping us in a box. And then if I dig in another area of it, and that's where you see some of the stuff that Nick talked about in IAM, but with security operations and SIM, that's bringing those pieces together. SIM is intrinsically that, how do I bring all the eyes back together? So while yes, you're solving it with taking a I trust nobody approach, sometimes called the zero trust approach, putting the right identity and access controls in, using the machine learning and analytics. But for SIM's job is to focus the security operations team on what really matters and maximize that efficiency and effectiveness of how they detect and react to those threats. And what I found fascinating here is that I don't see very many places where SIM is used as that glue within the supply chain explicitly. We may have a piece of it here or a piece of it there, but I really don't know of any real areas where the supply chain is thought of in a total systemic way, that the security operations team is working with its stakeholders and constituents in these other areas and really looking at this problem and analyzing it and doing the analysis in the way that we could. And where, if you look in the ArcSight platform, for example, we use a layered analytics approach. So we don't just rely on AI ML. We don't just rely on event correlation. We don't just rely on supervised machine learning. We rely on all of these different analytical methods within the ArcSight platform to use the best analytical tool to detect the threat, because there are different threats that you're only going to detect in certain ways. And I'm seeing that very much as I listen to the supply chain discussion going on here, is that type of breadth of using those layered approaches to analytics, the orchestration and automated response capabilities would play a great role in helping give better eyes and ears over the supply chain. It's just something I don't see a lot of organizations really taking on right now. And I'd be curious amongst my peers if I'm seeing it wrong. Dylan, am I missing something? I just don't see these cross-connects happening the way that I think they probably should.
I think that's pretty consistent, honestly. I think we're at a phase where there's a bit of pushback. I think to your point of, well, we don't want to slow down development. Well, I would kind of turn that back and say, it would probably be heresy if you weren't having your SIM monitoring, all the usage of your CRM tool. But has that slowed down the operation of sales teams and go-to-market teams to execute on securing new business? Of course it hasn't. It's a force multiplier. Just looking at some simple use cases in the AppSec space, you want your dev team focused on, doing pull request reviews, right, to catch bad code that's incorporated and deliver better code. You don't want your dev team responsible for understanding login patterns and exfiltration of data, like Stephan just described. So the fact that this represents a huge opportunity to improve the security of the supply chain, while actually helping, I think, the app dev organization and the business units move even faster by partnering with the security operations side.
Mm-hmm. Yeah, I'd like to add to that as well, is that I think, this is always a perennial challenge, right? Where, It's trying to get the different parts of the organization to work together. And in a lot of cases, we've had situations where, security was an afterthought. It's like, oh, I'm going to worry about what I need to do for my immediate deliverable. I'm not going to involve the security team. And what we really are talking about here is that these best practices, and I think this is really kind of emphasizing this, is we need to bring this together and have all this stuff work together in concert and think about this more systemically. When you do that, you get a tremendous amount of additional value. And making security part of the process rather than apart from the process is absolutely essential. And so I think that there's some of this is carrot and some of this is stick, right? Is that a lot of people have been starting to improve their maturity by adopting some of these best practices in advance. But I think that going back to my initial comment around the executive order, there's kind of a forcing function that's starting to kind of push in that direction too, saying we really need to get a handle on this, and we really need everybody to work together toward that end. And I think that it's kind of that combination that really emphasizes this more holistic approach, and to really look at how all of these capabilities can really benefit by bringing them together and working in concert.
So, it's really interesting because I like your thing, working together in concert. And what was so cool about that is I think of SIM in a lot of ways as and how SIM has evolved over the last several years as a conductor of an orchestra. And then I look at the rest of our portfolio, and I see we have the percussion section, we have the woodwinds, we have the brass in our data security, our analytics, our AppSec, and our different areas. And anybody who has a music background, that if the conductor only focuses in one section, well, the music may all be the same. It may be they're playing the same sheet of music, but it's not going to sound as good as when the conductor is able to look at the whole and conduct those different sections in pardon the pun, in an orchestrated or methodical way that brings that music to life. And that's kind of the things that I'm getting from this discussion today, is that we have the orchestra, and we have CISOs, and we have executives, and we have people in different areas that are looking at maybe sections within the orchestra, but we still seem to have a hard time really conducting the symphony in one piece. And so for me in SIM, that's one of the key areas that when I look at where are we going, what are we doing, how do we advance the SIM discussion, it's how do we give that additional insight? How do we give the insight of the conductor in the expression of that music? How do we provide that to the security operations team? And in turn, how do they feed that to the business in terms of the risk, and then help amplify the use of the other sectional parts in their respective ways? So those are my thoughts for what they're worth.
No, thanks, Mike. And thanks to all of you. Really appreciated this conversation. Excellent discussion. The only thing I'd like to add at the end here is, the whole software development lifecycle that many of our companies are managing internally. The pace is moving faster and faster. It used to be multiple releases maybe twice a year. Now you're releasing every week, maybe even every day. And we move faster and faster as we become more agile. And that creates additional risk in the organization if you don't have the proper controls, the proper critical software to help manage and understand your risk and react to those threats. So something to keep in mind. But to our audience, I hope you found today's discussion informative and useful. The replay of this keynote will be available, and I encourage you to share this discussion with your security colleagues. Please visit our website, cyberres.com, to learn more about how you can help your company become more cyber resilient. And looking forward to seeing you guys again. Thank you very much.